Hello, everybody, and welcome to the next episode of Tech Bites, bite-sized tech talks for teens. My name is Andrew McLean. I'm the co-founder of HighTechU and your host for today's Tech Bite session, but not the presenter who you're going to get a chance to meet in just a second. So before we get started, if this is your first Tech Bite that you've ever been to, just a little bit of background on what these are. These are our attempt to introduce you, the teens of the world, to some really interesting tech topics presented by folks that can make it really accessible for you through some really great hands-on activities that you can access most of these right from home. So before we jump right into who our presenter is, I want to just show you some great graphics, because that's half the reason that, of course, you're here, is to see the awesome graphics that we created for our session today. So Tech Bites, bite-sized tech talks for teens. You can see a whole bunch of logos around there. So we've got Tech Bites, the University of Victoria Faculty of Engineering, HighTechU, which is the organization putting this on, and then specifically for our Tech Talk today is our friends at the Department of Electrical and Computer Engineering here at the University of Victoria, who are the presenters of today's session, which is a tinkerer's introduction to sensor circuits. Now, I'm going to introduce you. I know I've been building this up. I'm going to introduce you to our presenter for today named Mateo in just one second. But before I do that, I always forget at the start of these calls to say subscribe. And in fact, in this video, somewhere around here, I'm going to add a subscribe button that you can click on so that you can know anytime that there's a new video updated for HighTechU. But with all that said, we're going to introduce you to Mateo, and as we're going through the Tech Talk today, if you have questions that come up, you can head over to our stream chat, and in there is our amazing moderator, Flight Wizard, who is there to help moderate some of the questions, and we'll make sure that we are able to get them answered in the call. And our presenter, Mateo, is available to help out with any of those questions that you have as we're going through. So with all that said, I think we're ready to get started. And without further ado, I will introduce you to our presenter, Mateo.
Is it on me?
It's on you. You're good.
Okay. Hi, I'm Mateo. I'll be doing the presentation for today. And why don't we get started? So here's the slide. This is visible. So today we're going to be talking about ambient light sensing, specifically using a photodiode. So a little bit about me. So I got a bachelor's in electrical engineering from UVM back in the States and worked as a design engineer at a company called TinkerCAD for a little while. And I'm currently completing my master's in computer science here at UVic. So let's start with photodiodes. So what is a photodiode? So the design is similar to an LED, which you might notice from the circuit symbol down at the bottom. And what it does is that it converts the light that it detects into a current. So to go over the applications, a few of the ways that you see them is in smoke detectors. So the way it works in a smoke detector is that inside the smoke detector, there is an infrared light in this photodiode, and the infrared light is basically shining a light toward the photodiode, which converts it to a current. And in cases of fires, there's smoke happens, and the smoke goes into the smoke detector and disrupts the light between the LED and the photodiode, reducing the current, and that's what the smoke detector notices and when it turns on. So in phones, if for most smartphones, there is an auto light, which or auto ambient light. What it basically does is it changes your brightness based on the ambient light, and so this works as similarly in the sense that it basically just changes it reduces the light as there's less ambient light in the room and increases it when there's more. And lastly, for a health application, pulse oximeters, which you may remember from the doctors, are the little pieces that they put on your finger that measures your pulse and heart rate. same thing. So the way these work is that similarly there's an LED on one side and a pulse in a photodiode on the other. It shines a light, and based on the blood flow through your finger, there's a delay between when the light hits the top of your finger and when it reaches the photodiode on the bottom, and that's what the pulse oximeter reads. So going from applications, we're going to be using this in a Arduino setup. So a short overview. So the types of pins we're going to be using today are digital pins and analog pins. And digital pins are just on-off, other than the PWM pins, which can be used as a analog write, 0 to 255. And then analog pins vary between 0 and 255, which you get is it's kind of like on and off with a it's varied. And so let's go quickly to a circuit. So here I have a simplified circuit for a photodiode. What's basically doing is that there is a photodiode connected to the analog inputs of the Arduino with an LED as well connected to a digital output of the Arduino. And so going back to the presentation, we're going to quickly go over LEDs just in case anybody has any questions on that. So most LEDs, you don't want to go above 25 to 30 milliamps, and the average is usually around 10. You don't really have to go much higher for that. So we're going to be, what we care about is that LEDs have a forward voltage, which is basically, you can think of as like a subtractive voltage, which plays into our calculation for a resistor when we're doing determining a resistor to use with the LED. And for the calculations, we know the voltage going in to the LED, which is the 5 volts coming from a Arduino. We know the subtractive voltage, which usually you can find on a data sheet, but in this case it will just be 1.8 volts. And we know the current that we want. So let's go to the next. So this is also going over Ohm's law. So Ohm's law shows that I, which is the current, is equal to the voltage over the resistance. Oh. Yes. Is that better? Okay, so we know the two voltages, like I mentioned, the source voltage and the forward voltage. And in order to find the resistance that we will be using, we use this calculation here. So for this case, we could just use about 12 milliamps. And if we want to find the resistance, what we'll do is that we switch the I and the R, and we see that 5 volts minus 1.8 over 12 milliamps, which is 0.012, is equal to the resistance we want. And doing that calculation, it is about, let's see, 5 minus 1.8 divided by 0.12, 266 ohms. So we can use that for our resistance. Let's go back to the circuit. So in this circuit, what we do is that we have the anode side, which is the positive side, connected to the analog output, and then a resistor connected to both the cathode side, which is the negative side, connected to both ground, and a resistor also to the analog input. So what this is basically doing is that the current wants to flow down through the diode from the positive end to the negative end. And when it does that, it goes through the resistor that we're using. In this case, I used a 10K. And you get the voltage up on the positive side, which is going into the analog output. So if I was to show the code for this, what I did is that I basically just set the LED and the photodetector as the pins that I want. I read the pin, and I check to see if the value is greater than a certain threshold, And then if it is, I turn on the LED. So if I was to start the simulation, so I'll get rid of this. I slowly up the voltage or the light shown for the LED. So in this case, because of I have it very high, so the LED doesn't turn on until all the way, but the LED will turn on. And basically what this is showing is that as the ambient light increases for in the room, it changes whether or not an LED will turn on. I also have another circuit that I want to go over. This one's a bit more complicated. It uses something called an operational amplifier. So it looks like this. So the way an operational amplifier works, I go over to here, is that so I have these pin 4 and pin 7 basically act as mins and maxes for what you can get as an output. So I have pin 4 connected to ground, which means that the lowest I can go is 0, and pin 5 acting as a 5 volts, which means the highest I can get at the output is 5. I then have this photodiode connected to the negative input, and I have the positive input connected to ground, and this 12K resistor connected to the output. So current for this operational amplifier goes backwards, down, back through here, back through the cathode side of the diode. Obviously, the diode wants to flow this way, so it produces downwards, so it produces a negative current. This works well because the operational amplifier, when connected to the negative side, would normally produce a negative voltage, but due to this, produces a positive one, and so the voltage that we get at this output is equal to the current going through here, multiplied by this resistor. So if we go back to this circuit, I have it so it's set up. This one's more sensitive. That is the goal when I made this circuit. So I have it just set so that if it reaches about halfway through, roughly, it will turn on. So if we start this simulation, we can even see the serial monitor. As I change this photodiode, the value is slowly going up, and I can get to 155 pretty quickly, around halfway. And at that point, it turns on the LED. One thing I want to go over, just as might be useful. So for photodiodes and LEDs, they have roughly they can have roughly this the same design. And for determining the anode and cathode side, usually for the anode, the positive side, the wire coming from it will be longer. That's usually a good indicator. And then also the side of the cathode will be flat, which can be relatively seen here. So it flattens here and it's curved on the other side. For the photodiode, you can usually find it out the same way, or it will just have a indicator of a plus and minus. So just as a quick check, is there any questions? Okay, let's see if I have anything after here. So let's see. Yeah, so if you notice, for both these designs, we have it set up so that it's going to the analog output instead of directly to the LED. The photodiode produces a very small current. It's usually between 3 milliamps, not 3 milliamps. It's in like the picoamps to roughly 3 milliamps at its max. So it's not. It's usually too small to directly connect to an LED, so usually it's used as a sensor in this case, like in this application. I think that's roughly what I have for this. But I am available to answer any questions along the lines of applications to use on this or different ways of setting up a circuit with it. Okay, yeah, I mean, one way you can set up a circuit for this in a different way is so that I have it so that this pin is, so I have the resistor to the A0 and this pin to ground. I can set it up differently. So basically change it so that this resistor is connected to the A0 and I just do this to ground. The downside to something like this is that the sensitivity gets much lower. It varies between, in analog terms, 68 and 85, which doesn't make it ideal, which is usually why you would use something like an op-amp. So I can actually show that. So if I go to here, I'll just say like 75. So as I change this up, it goes directly to 70. And so I get to 77 before I get even like a third of the way there. And so for most applications, I would say that you should use an operational amplifier or some variant in order to achieve the sensitivity that you want when using a photodiode. I say that's roughly it.
Awesome. Well, thank you so much, Mateo, for that amazing presentation. And am I right in thinking that you are going to be back with us for next Wednesday's Tech Bite as well?
Yes, I'll be going over, so the Arduino has 3 pins that kind of control like SPI. It's one of the ways you can use for connecting to the Arduino. For instance, if you want to program Arduino, you can use these 3 pins here as a way of doing it, and I'll just be going over more of the specific applications of some of the pins on the Arduino.
Awesome. And then if people are really interested in this and they've really enjoyed the last couple of things, where can they kind of take this knowledge and apply it in maybe the first week of July? What's happening?
So in the first week of July, we're kind of hosting a electrical engineering kind of like a project. So what kind of is going to happen is that we're going to spend about 5 days. So high school students, for example, can apply, and we will help them basically build a project that they want. There will be me, another electrical engineering master's named Vinesh, and a few others, and we will basically guide people through the projects that they kind of want to design toward like health or other sciences.
Awesome. Well, thank you so much for that, Mateo. That was great, and we're really excited again for next week's Tech Bite session. If you are here in the chat for Twitch, you can check over here and see all of the links that we're talking about. So if you're interested in finding out more about the ECE cohort, you can check that hightechu.ca link. And then just another couple really important things that you should, of course, know and be aware of, and we hope that you'll take advantage of. So the first thing is remember to follow us here on Twitch if that's where you're watching us. If you happen to be watching us over on YouTube, be sure to subscribe to us over on YouTube as well. And then, of course, a huge thank you to all of our sponsors and partners, including the Faculty of Engineering, the Department of Electrical and Computer Engineering at the University of Victoria, Coast Capital Savings, our many other industry and community partners, and of course, the most important Thank you so much to all of you for watching our live stream today. If you're interested in checking out more about HighTechU, you can head over to hightechu.ca. If you're interested in applying, applications are due tonight, June the 17th at midnight. So be sure to get your application in as soon as possible. And from all of us here at HighTechU, to all of you, thank you so much for checking out our Tech Bite session. This has been Tech Bites, bite-sized tech talks for teens. And if you're interested in knowing a little bit more and you're just catching the end of the session, this was our Tinkerer's Introduction to Sensor Circuits presented by the University of Victoria Electrical and Computer Engineering Department. Thank you so much for attending our Tech Talk today, and have a safe, happy, and healthy rest of your week. Bye.